Good morning, students. I hope you are doing very well. In the last my video lecture, we discussed about vector calculus, that is del operator, and del is a differential operator. It behaves as a vector, and this del is operates the scalar quantity and also vector quantity. If it operates scalar quantity, in the sense just del operator multiplies the scalar quantity, which gives the gradient of the scalar field. Similarly, if del operator operates the vector field, which gives divergence of the vector field or curl of the vector field, and were discussed in the last period. Now, what is meant by gradient of scalar field and its physical significance? You know, when del operates the scalar quantity or scalar field, which gives the gradient of scalar field. Now, question is, what is gradient? Gradient means simply it is a slope, means dy by dx, in the sense rate of change of scalar field with respect to distance, means here y is a scalar field or scalar quantity. I repeat, rate of change of scalar quantity with respect to distance, that is the gradient. So this gradient or slope is not zero or not minimum. It should be finite and it should be maximum. Means the slope should be maximum. That is, the rate of change of scalar field with respect to distance should be maximum. I'll give one example. As you know, electric field and electric intensity, means electric intensity and electric potential. So electric intensity at a point in electric field is the force experienced by the unit positive charge. Or you may write electric intensity is the negative gradient of electric potential. You know the relation between electric intensity and electric potential, that is E is equal to minus dV by dr. Here E is the electric intensity, V is the electric potential, the rate of change of electric potential with respect to distance, that is minus dV by dr, and as you know, this is equal to minus gradient of V. Gradient of V, you may write minus del V. We will prove it. See, here you take a point positive source placed at a O, then you take two surfaces, that is you call equipotential surfaces. One is S1, another one S2. S1 is placed at a distance R from the O, and S2 is the placed at a distance R plus dr, where dr is the perpendicular distance between S1 and S2. The both are equipotential surface. Equipotential surface, as you know, the potential at all points on that surface is same. The potential at surface S1 is V. The potential at surface S2 is V minus dV. Means as you move from the source, the potential will be decreases. So S1, S2 are the equipotential surfaces. As you know, the potential means nothing but work done. So electric potential means amount of work done to bringing unit positive charge from infinity to that point. Infinity to that point. Suppose the potential difference between these two surfaces, that is S1 and S2. In the sense, the work is done moving the positive charge, unit positive charge from B to A. That work done is equal to work done moving unit positive charge from B to A, that is VA minus VB. Means at the surface S1 is the V is the potential and S2 is the V minus dV. Then work done per unit charge, that is V minus V plus dV. Here you know the definition of work. Work is equal to what? Force into displacement, that is F dot dr. Naturally it is a dot product, F dr cos theta. I put the negative sign because the work is done against the field. Then theta is equal to 0 and F is equal to EQ. As you know, electric intensity is equal to force experienced by unit positive is equal to F by Q. And substitute here, that is minus EQ dr cos theta, where theta is equal to 0 degree. So naturally per unit charge, so QQ get cancelled, dV is equal to minus E dr cos 0. Cos 0 is 1, E is equal to minus dV by dr. Or you may write E is equal to minus gradient V, or you may write minus del V. So here the rate of change of scalar field, it should be maximum. And finite. Means what is the physical significance of this gradient of scalar field? As you know, when you apply the gradient, means del operates the scalar field which gives the gradient of the scalar field, and that gives the vector quantity. That is important, that gives the vector quantity. And what is the physical significance of this? I'll give one example. You take two surfaces, one is A, another one is B. At A, or you call here O, pi is the field, flux, you say flux in this surface, and phi plus d psi is the flux on that second surface. And what is the rate of change of flux in these two planes? Or you may write psi is equal, or pi is equal to phi minus phi plus d phi is equal to, you will get d phi. Means from 0 to B it is a d psi, and again 0 to A it is also d psi. Means the rate of change of flux from A to B is less than the A to, means 0 to A. Means at normal surface the rate of change is maximum. That is extremely important. Means the gradient means maximum rate of change of the scalar field normal to the surface. That is the physical significance. In the sense, it gives the direction, maximum rate of change of scalar field with respect to distance. That is the physical significance of the scalar field. I repeat, the physical significance means thus it gives the direction, means it gives the vector quantity, and rate of change must be maximum with respect to distance. So this is the physical significance of the scalar field. Next period we will discuss what is the divergency of a vector field, what is the physical significance of the divergence of the vector field, and similarly curl of the vector field and physical significance of the vector field in the next period. Thank you.